Hey guys, let's discuss a new question from system design topic, which is called design AI-powered Facebook or Instagram type newsfeed application. Okay, so here the problem statement is we need to design newsfeed. Okay, we need to design newsfeed or home feed like Facebook newsfeed, Instagram or LinkedIn. Okay, so in LinkedIn, Facebook, Instagram, we see the post, we can post and we can see the other people's post. We can have the infinite scrolling and it will get refreshed in let's say 30 seconds, right? So that kind of system we need to build here. When user open the app, he can see post from friends or following, okay, and then images, video, reels, likes, comments, and sponsored advertisements, suggested content, and then ranked personalized feed. So here ranked personalized feed will come from AI. Okay, AI will assign some rank to the post. He will run the algorithm behind in background, and then he will assign some score to each post, and then will display the top content to you. What will be the functional requirement here? So core feature, if you talk about the feed related functional requirement would be if user open the app, he can see the post. That is the very first thing. Second, infinite scrolling. Okay, means we scroll, we just scroll and we see the post, right? So refresh feed also, okay, in every 30 seconds or something. Then like, comment, share option to do that on the post. Follow, unfollow user. Now if you talk about the content related functional requirement, then it would be text post, photo, video and reels. Okay, this kind of content he can post. Now second thing is here ranking. Okay, so personalized order, there should be a personalized order. For example, I can see on my homepage my post from my friends, okay, and you can see on your homepage it would be personalized, right? Whoever is your friend, you will see his or her post, so it is personalized. Okay, and then advanced, if you talk about some advanced features, so advertisement insertion, okay, and then suggested creators, some other creator he can suggest you. If you have seen, let's say, coding videos, then he can suggest you the top creator from that field. Then trending post also, and notifications as well. Now if you talk about non-functional requirements, so it would be the same performance, availability, right? If you talk about performance, feed first page in less than 200 milliseconds. See, lots of user use Facebook and all, okay, we see every time the first page only, okay, rarely we go we scroll and then we see the other pages. Not rarely, but as compared to first page, the other pages we don't see that much, right? So first page just load in less than 200 millisecond, okay, and then scroll smoothly. So it should not like I'm scrolling, okay, then 3 pages came, like let's say 20 posts in each page, okay. I have seen all those posts, and then I'm scrolling and then I'm seeing that buffering, okay, the buffering symbol. So that should not happen. It should be smooth. And media lazy load. Media lazy load means the media files you have, audio, video, okay. So lazy loading, you can do that. So as you're calling that services, that page, then only it will fetch that kind of media for you. Now reliability 99.99%, okay, the system should be available. And consistency, so here we will accept eventual consistency. Why? See, it is okay to let's say I on my post I have 100 likes, okay, and let's say some network issue happens, so it's okay if I don't see the new 2 likes, okay. I will see the old data on the 100 likes. Later it will eventually it will update that after 2-3 seconds. So that is fine, but it should not be the case ki I'm not seeing the application itself, okay, the page itself. So here availability is important. Consistency we can take as a trade-off, okay. So eventual consistency is acceptable here. Strong consistency, that's okay if it's not there. Now example, like count may show 101 now and 103 later, that is okay. Now capacity planning, so this is the important one. See, let's say you have 600 million daily active user, okay, 600 million daily active user you have. So now average user open feed 5 times a day, okay. in one day you are opening the app 5 times, and average session request is 3 page. Okay, so 3 pages you are checking and then you are logging out, and average page size is 20. So it means that 600 million user you have, he is checking 5 times in a week, okay, your app, and then he is scrolling 3 pages, and in each page 20 posts. So these many posts should get load on your app for that particular user. Now here feed read request, if you talk about, so you have 600 million user and 5 times each day he's checking the app. Okay, so it means that 600 million into 5, how much it would be? 3000 million. Okay, 3000 million means you can say 3 billion, because 1 billion is equivalent to 1000 million, 1k. Okay, so means 3 billion request 3 billion feed opens per day. Okay, now if per day it is 3 billion, then how much it would be for per second? So 3 billion divided by 24 hours and 3600 second for each hour, so it would be somewhere around this number, 34,700 requests per second. Okay, and peak traffic, just include it, like multiply it by 10. Okay, so it would be somewhere around this is 35,000, right, request per second, so it would be 350 request per second, 350,000 request per second. Now here scroll pagination request, so you're scrolling, right, at the end you're using pagination only, but it's the different kind of pagination. You're not clicking on 1 page, 2 page, 3 page, you're just scrolling, and during infinite scroll it is fetching the pages for you. So scroll pagination, if you talk about, so you have 3 billion open things, right, request, and then user is checking 3 pages each time, so it would be somewhere around 9 billion page request per day. Okay, and then post creation traffic, so let's say 10 million post per day, because see, if we don't post every day, okay, let's say user is posting once in a week, okay, or you can say that 115 writes per second average, so he's just checking. So from here we have derived it, 10 million post per day. Okay, if 10 million per day, then per second it will be somewhere around 115. Okay, so and at peak just multiply it by 10, so it would be somewhere around 1000 write post per second. Okay, 1000 write request we required here. Now likes traffic, so if you see the post, we see the number of likes also, right? You cannot go each time to database and check for that particular post how many likes are there. Okay, you cannot fire a query. We will store that in a cache using key value pair, right? So likes traffic, if you talk about, let's say people are liking 5 billion posts per day. Okay, so it means that there are 500 billion likes per day you have, so it means that per second you would be having somewhere around 24 into 3600, like 5.7 million per second average events. Okay, so liking is also an event. When someone is liking it, it will go to Kafka cluster, and then there it will process it. So yeah, so here it is given that handled asynchronously via Kafka. Okay, so let's say I have liked it, but there is some network issue, so it will go to Kafka and then will process later. Okay, so here anyways we are using these eventual consistency. So overall scale, if I summarize it, whatever we have calculated right now, so it means that you have 2 billion registered user, okay, in which 600 million daily active user you have, and 250 million user open feed per hour. Okay, and then 10 million new post per day, 500 billion likes per day. So this is the numbering. Now high level architecture, if you see here, see, user has open his let's say app on mobile or Facebook. Okay, the request will go to CDN, content delivery network. From there the request will go to load balancer, API gateway, okay, and then feed services. So now feed services will send this will fetch data from either candidate generation. Okay, so it will generate candidate for you, top post for you. Okay, will run the AI ML algorithm in backend, and then will generate some let's say top 20 post for you. So it will fetch from there. Ranking ML, which will rank the post. Okay, after that advertisement services, and then cache Redis. From cache it will take the number of likes and all those things, and then feed is stored. From there it will collect the data, and then will show it on the user screen. Now if you see the post publish flow, so when user is posting a let's say some post, okay, publishing some post, then what will happen? So user will publish a post using the post service, okay, then it will go to Kafka first. From Kafka, you will have a workers, okay, and then what those workers, and we call it Fanout workers. So Fanout workers, what it will do, it will so each user will have his inbox, okay, and then so he will deliver that post to each in user's inbox, feed inbox, okay. So you will say, see here two things are there. Let's say there is one celebrity and there is one normal user, okay. So let's say I am a normal user and I have only 100 friends in my application, so in my network. So I will post, okay, so I have a less number of friends, so he has to do 100 writes operation, okay, to deliver that post information to each person's inbox. Okay, so here he will use Fanout write, okay, he is writing in each person's inbox. Now there is a one more strategy which is called Fanout read. So in that case, let's say there is one celebrity and he has millions of followers, okay, so system cannot go to that millions of followers inbox feed and write that post. So he'll write at one particular location, and then when those followers will come online, they will fetch data from this place, and then we'll see the post, okay. So definitely this one is slower, and for me it would be faster. So that is how the strategy is there for the write post. So here, that's why this Fanout worker will write that into the feed inboxes, okay, those messages. Now important inside feed is read heavy, okay. We know that it is read heavy because if you see, user read far more than they post, okay. You're posting once in a week, but you're reading every day, that too multiple times. One user may post once a week but read 300 posts per day, okay. So optimize read aggressively here. This system is read heavy application, this application is read heavy application. So now core data model, if we talk about, you will have a user table which will have the information of user ID, name, profile picture, privacy type, okay. Now the second one is, means my profile is my account is public or private, that is also. And then post would be post table will have the post information, post ID, author ID, who has posted it, okay. Then caption of the post, media URL, if he has attached any photos or videos in it, so that's URL. That photo we will store in S3, okay, AWS S3 or any cloud services, and its URL we will store in a database, so that URL will come here. And then created at visibility, whether it is a private, public, or just few friends, okay, and the type of the post. Now follow graph will have, see, these kind of application where like Instagram, Facebook, okay, LinkedIn, at the end what is that? They're using the graph they're using the graph data structure, right? Because I'm following someone is following someone, okay, so it is like a graph only, right? He's my friend, he's someone else's friend also, then we have a mutual friend. So this is the graph data structure. So you will have a follow graph table which will have the follower ID and following ID, okay, and then created at. Now likes table you will also have. So likes table, you cannot go to means you cannot have one table and post, let's say in a post you are adding one like table, whether then this user ID like table, okay, that this user ID has liked this post and all those things. So you cannot do that, it will take a lots of time. That's why we have created the separate table for like itself. So whenever you are seeing the some post ID, it will go to that table and check the it will go to that post ID and check the user, okay. So likes table will have the user ID, post ID, and created at. Now feed inbox, okay, so this is what I was talking about. It will go to feed inbox, each users will have the feed inbox and will go and write there. So let's say whenever you are scrolling something, okay, from longer time, so you will see that the new post, whenever you will go top, okay, you will see the new post, or you will refresh it, you will see the new post, what it is doing. So when someone is posting it, it will come and add in your this feed inbox table, okay, and when you are refreshing it, you will see that at the top. So now here you will have a user ID, post ID, score, and then inserted at the timing. Now storage decision, if you talk about that, see, we are using here multiple types of storages. Like for example, for user table, we will be using a relational database, okay, relational database like MySQL or Postgres, okay. So why? Because here you would be required strong consistency, okay. You know that a relational database have the ACID property, okay. So whenever there is something related to transactions or user profile update or strong consistency, you would be required there the relational database. Then post metadata, so post table you will store, you can use see, post can be a lengthy one, okay. So you would be required the wide column DB there, okay, and like Cassandra or scalability, okay. Why? Because you have a massive write throughput and time series friendly and easy horizontal scaling. You can scale it also. MySQL you cannot do that. So here you will now it is, you can horizontally scale it. It means that you can shard it the database, okay, and you will use the shard. For the sharding, you will use the partition key. Partition key would be your author ID and post date bucket, okay. Now feed inbox table, if you see, so feed inbox also we will use Cassandra and DynamoDB, okay. And why? Because need quick read of top and post for each user. So when user is logging in here, so we are showing him post from this feed inbox table only, and we will fetch top and top and post only, because we don't go to at the end and check all the posts, okay. We just check the top post only. That's why we will be using then Cassandra or DynamoDB. Now likes or comment counter, okay. So here use Redis first, then async flush to DB. Example, like you have a post 123 and its a number of like is 23 lakh 112, something like this. Because means you are pre-calculating your number of likes for the post and you're storing that in a cache, because it would be very complex if you go to for particular post, you run the query from database and get the total count of the likes for that particular post, okay. So that's why, so here that's why we will be using Redis, because it is a key value storage. Now for search or hashtag, we will be using Elasticsearch and OpenSearch, okay. Now sharding example, if you talk about, so shard feed inbox by hash user ID mod n. And why we are using here this hash function? Because it will distribute traffic evenly. Now one database should not serve every workload, okay. That's why we are using multiple databases. Feed generation strategies. So here I have already talked about Fanout read and Fanout read and write, okay. And so you just go through it, normal user, celebrity user, and the normal user post, okay, celebrity post, if you see. So that is how they work. So for celebrity, what will happen? Let's say Taylor Swift post teaser, okay, and then his followers are very huge here, okay. So save post once and make creator as celebrity tier. So now that creator will come to celebrity tier. So that is how you will come to know that you don't need to fan out it for the all users, okay. Do not fan out to all users. Followers fetch dynamically during next feed request, and cache hot results, okay. Then save massive infra cost. So the same thing is there. So feed read flow, if you check, if someone is opening the Instagram, let's say, so feed API, it will call the feed API. Feed API will go to Redis cache and fetch the data from there. If it's not there, then he will, if it is cache means, then he will go and get the candidate, okay, from the database, top 20 candidates, and will rank those 20 candidates, okay, and then cache that first page into the cache, and then will show that data to user. Candidate generation, if you talk about, see, you will have a millions of posts. Okay, so for particular user you cannot pass all those millions of posts to machine learning algorithm and then it will fetch you top 20. Okay, that should not happen. It means that first you need to collect 1000 candidates, 1000 posts. Okay, and how you will collect this means how this application will collect that 1000 posts from millions of posts. So he will see following post. Okay, following post means recent post from account user follows. Okay, I am following one account, so there I got some post. Okay, from there it will take some post from friends. Like also my friend is liking something, so it will get that post also for me. Similar interest. Okay, similar interest means one more user is there, so we have a similar interest. So if he is liking something, so he will show me that as well. And then trending nearby, whatever is trending. Okay, now advertisement also it will give you. Okay, so then he will combine these posts, 1000 posts, and then it will give it to machine learning algorithm. So like then advanced ML ranking pipeline, and then ML will rank these posts accordingly. So for example, multi-stage ranking architecture we use here. So like ranking 1000 candidates using deep machine learning is expensive. Okay, so again this 1000 candidates, see, from millions of candidates system has found the 1000 candidates. Now these 1000 candidates also you cannot give it to system, because deep ML system, because they are expensive. So what he will use 3-stage pipelines. Okay, so now first one will be a lightweight filter. So lightweight filter, what it will do, stage 1, remove spam, blocked or duplicate post. So now from 1000 you will have 400 candidates. Okay, now fast ranker. So he will use XG boost or light GBM. What he will use some feature like freshness of the post. Okay, the newly created post, and relationship, like whether I have some mutual friend or friends post or something like that, and then CTR probability. Okay, click through ratio means probability means user will click that post or not to read further. So these feature he will take and then will again filter the post from that 400. Let's say he has selected top 100 post. Now here the latency target will be less than 20 millisecond. Okay, now third stage will come where the deep ranker will come, and deep ranker use neural network and embeddings. Okay, so embeddings, you know that we store in AI data in a vector format, and that too in vector format we store data in the numeric format. Okay, it will convert it into the numbers, so those numbers will call the embeddings. So here the signals will be like content similarity, user embedding, creator embedding. Okay, watch time predictions. So all these things he will take into the consideration, and then will further filter from 100 post to 20 post. Okay, and then those 20 posts will show on the screen to the user. So user watch coding reels, let's say. Okay, so embeddings find system design reels, coding meme, and then Java tutorial. So even if user is not following these creators, but it's still it will show the content from these three creators. Now there is another strategy, explore versus exploit. Okay, so what is explore versus exploit here? We need balance here. Okay, so it's like let's say I have only I'm seeing Java video lectures. Okay, so it should not like I'm getting only Java lecture reels only in my Instagram feed. Okay, there should be a balance. First he will show continuously he will show 10 reels, and then he will show me some another category reel, and then after some reel he will again show me the Java reels. So there should be a balance. Okay, so here the concept comes exploit. Exploit means known interest. Okay, show known interest like Java videos. Now explore, what is explore? So show one or two new category. Okay, maybe user like that. So for example, user watch cricket only, so inject finance reel occasionally. Okay, could create new habit, financial, so he will start seeing the financial videos also. Now training pipeline. So see, if this it is offline, then in that case last 30 days clicks he will take into consideration, the ML algorithm, and the likes as well, and then watch time as well, and then he will train the model daily. Okay, if it is online, then use fresh signals instantly. So ranking engine, if we talk about here, so now rank 1000 candidates to top 20. Okay, so what will be the formula? Formula will be something like this. He will find the score, and that score will combine with some embeddings like relationship strength, okay, engagement probability, freshness, watch time prediction, content quality, and diversity bonus. So all these things, it will give some embeddings to numbers to this, and then will calculate the score, and on according to that score he will order the he will rank the post. So feature example, if we talk about here, like whatever we have talked here, right, relationship, engagement probability. So let's let's see that. So relationship strength means how often you interact with author, so that one will be the relationship strength. Example, if user chats daily with friend, so friends post rank will be on higher position. Engagement probability, will you like the comment or not? So ML will predict that, okay, based on your past history. Freshness, so recent post boosted. For example, 10 minutes old, 10 minutes old probability will be more than the 10 days old post, right? So freshness matters here. Watch time, for reels, if likely to watch full video, then boost, okay. So if when you are scrolling the Instagram and you are seeing the reel, okay, so it will calculate the watch time also. If you are seeing someone's photo image, then it will see the pause time also on that photo, that how much time user has spent there, and then according to that it will calculate your next feed. Diversity bonus, avoid 10 cricket posts in row, okay, mix the category. Now real example ranking, if you talk about, so user follow best friend, cricket page, and food blogger, let's say, okay, 3 things he is following. So in that case, let's say candidate, okay, so now he will give some score to it. So for example, best friend wedding, he will give the base score to 0.92, okay, for cricket 87, food, random meme 52. So final feed would have these 3 things which will have the highest score. Why Instagram feed feels smart, okay, why we see that it is smart? Because it uses signals like pause time on image, this is what I was talking about, okay, video completion rate, and then rewatch rate, okay, if video people are rewatching it, means it is popular. Share send to friends, okay, save or bookmarks, and audio reuse trends, like we use the audio, okay, in the Instagram reel. So that one also. Now caching strategy, if you talk about, so cache keys we use here, key value, we use the Redis, okay, key value pair. So so like for example, key will be feed user 123 and first page, okay, so post 999, profile 456, follower 789. So these things will be cached when you see someone's home page. So you will have this number of friends, okay, and the number of photos and all those things. So those things will come from cache itself directly, because first page cached for 60 seconds, because many users reopen app quickly, okay, if I'm reopening it, then it should be refreshed. So for 60 seconds only we keep this data there. Now why only first page cached, okay, this is very simple, because most users engagement happens to page 1 only, okay, deep pages rarely accessed, save memory cost. So excellent senior, means, yeah, if you are senior, then you can give it to in interview, you can say this. Now media delivery, so media delivery means whatever images, video you have, it will get served from CDN rather than from some server, okay. Example, so CDN examples are Cloudflare, Akamai Technologies, Amazon Web Services CDN, AWS CDN, okay. So what is the benefit here? First one is faster load globally and lower origin traffic. So you will have an origin server, then edge servers, then so like your application is served entire globe users, okay. So globe will divide it into the regions. You will have a region clusters, and then inside region you have a edge clusters, okay. So you will have an origin server, and then regional servers, okay, regional clusters, and then edge servers. So first it will check in edge server, if it's there, if it is popular, then we will cache it there itself. If it is not there, then it will go to region level, it will check there. If it is not there, then again it will go to origin layer and then fetch from there, okay. So lower origin traffic, okay, because we are getting it directly from edge servers, CDN. Now real-time updates, so here we will use WebSocket and push notification. Okay, so like push notification when you are not logged into app, okay, on your mobile locked screen you see the notification, that is called the push notification. And WebSocket we use here instead of HTTP, because HTTP each time you need to maintain a connection, but here we are using WebSocket, so only first time handshake will happen, and then again later you don't need to make the connections, so it will be faster. Now reliability and resilience. Okay, so reliability engineering, if we talk about, if you're, let's say your Redis failed, okay, your Redis failed, then what will be, how you will handle that scenario? So you will have a fallback mechanism like read feed from inbox db. Okay, each user will have the inbox db, so you just read feed from there. It would not be the fresh, but the your system will be available, right? Smaller page size, and then disable expensive ranking. Okay, for that time you can disable it for particular time. Now if there is a Kafka lag, if Kafka delayed, so new post delayed in the feed and existing reads continue. Okay, system degrades gracefully. It's not like the system is not working itself. It will show you some old data, but it will show you some data at least. Now duplicate events. So Kafka retries many duplicate posts. Fanout. Okay, if Kafka is let's say one user posts something and Kafka is writing it to other user, what if he will duplicate it? In that case the user will see the duplicate post again and again. It should not happen, right? So there we use the idempotent key like user ID and post ID. So insert only once. Now dead letter queue. So dead letter queue is something, let's say you retry, but still if it is not working and you have given some retry counter like 5. So after that we will push that particular event to dead letter queue. Okay, and there then the person will check and see manually what is happening there. So we process it later. Now circuit breaker. So if ranking service is slow, use backup heuristic rank. Now what is heuristic rank? Heuristic ranking means ranking content using simple handcrafted rule or formula instead of heavy ML models. Okay, so we will use the heuristic ranking there if ranking service is slow. So here freshness plus relationship score. System should degrade, not collapse. Now handling hot users or viral post. Okay, so let's say if one reel goes viral, so need protect db, right? Now we need to protect db because everybody will come there and then make a request to db. So in that case what you will do, you will first store that video to cdn so that your db will be protected, and then we use the redis hot cache. Okay, so it will read from redis itself, will take lesser time. We will make some replicas and async counters. Now here let's check what is async counter. So take one example, like if post gets 1 million likes in 10 minutes. Okay, so do not update db row 1 million times directly. Instead like service, you have the like service. Okay, like Kafka aggregator batch update counter. So write that like counter to Kafka, okay, or just write it to aggregator, which will aggregate all the likes or the batch services. In batch you can update in the db. Now consistency decision. So definitely we talked here about do we need a strong consistency? No, eventual consistency is okay here. So need strong consistency for advertisement billing. Okay, hybrid you can say, and for payment related things and account security. So all there we would be required the strong consistency, otherwise eventual consistency is okay. Like count delayed by 2 seconds is acceptable here. Now privacy filter, if you talk about, so before showing candidate, okay, candidate means post, before showing post to the user, first you check whether this is coming from blocked user or not. Okay, and then muted account or not. You have muted some account, so it should not you should not see the post from that account. Private account permission, age restriction, geo restrictions. Okay, so example, if user blocks someone, never show content from that user. Now abuse prevention. So need to detect spam pages. Bots like, okay, bot can also like multiple means can like a post. Okay, so we need, your system should detect that as well. Fake engagement and harmful media. Okay, so use ML moderation pipeline for that. Multi-region design. So user in India should hit nearby region only. I told you that region and then 8 servers, right? So you have multiple regions like India, US, Europe. So use nearest serving region. And replicate asynchronously as well. Okay, means it is reading from one region, you're writing some post in one region, and asynchronously it is writing in another region also, so that tomorrow if that region gets failed, it will take the data from the other region. Global traffic routing and disaster recovery. So geo routing is geo DNS based. Okay, so there what you will do, so Indian user will use the Mumbai location, Mumbai data center. US region will use the Virginia, so latency will be lower here, right? Data replication use writes happens in home region, replicate asynchronously globally. This is what we just talked about. Okay, now disaster recovery. So if Indian region fails, traffic shift to Singapore region, cached feed pages is still available. Now RPO and RTO. What is RPO? RTO. So RPO is recovery point objective and RTO is recovery time objective. Okay, so recovery point objective is maximum data loss you can tolerate, and recovery time objective is maximum downtime you can tolerate. So let's say if some failure happen. Okay, if some failure happen, so how much time your system will be down. Okay, you can make that. So that is called RTO. And then data loss, during that time how much data loss you can bear, that will come into RTO. Now cost optimization, if we talk about here, so see, the expensive areas are like Redis memory, ML inference GPU, okay, video bandwidth, cross region replication. These are the expensive area. What will be the solution for this? Cached only page 1, don't cache all the pages. Okay, batch inference, then compress image and tiered storage. So for example, in multiple storage you will have hot, cold, warm. Okay, so they will be expensive or cheap one, so just store that. Now you will have the APIs like slash feed. Okay, slash feed cursor XYZ, post, create, post like, follower, post report. Now trade-offs will be here, like see, if you go with Fanout write, okay, so this will be fast, but it will have the heavy write. Okay, Fanout read will be cheaper one, but the slow read. Big cache if you use, this one will be fast but expensive. Deep ranking if you use, better UX but CPU is very costly here. And then strong consistency if you go, so correctness will be there but latency would also be there. So you can say that I would use hybrid feed generation, Redis cached first page, okay, and then Kafka async event pipeline, ML ranking, scalability, pool model. For scalability we will be using pool model. Multi-region serving and privacy filtering before ranking. So that's it. Thank you.